Hello and welcome back. Here we are, number 4, week number 3, 21 mark problem, so pretty long one. I might split this up into 2 videos. We'll see how it goes. Tim throws 2 identical fair dice simultaneously. Each die has 6 faces, 2 numbering 1, 2 with 2, and 2 with 3. His score is the sum of the 2 numbers shown on the dice. I'm going to draw a sample space for this and then come back and explain. All right, so here I have a sample space. Here's die number 1 in red. Here's die number 2 in black. And then here are all the scores that Tim could end up accumulating. So if he rolled a 1 and a 1, he'd get 2 total. So we'd add those dice. So part number 1 here asks, calculate the probability Tim obtains a score of 6. Now there's 36 different scores that he could achieve, and 4 of them are 6s. So the probability that this would be true would be 4 out of 36, which would be the same as 1 out of 9. Okay, and the second part says calculate the probability Tim throws or obtains a score of at least 3. So that would mean we could take 1 minus the probability that Tim scores exactly 2, right? Which would be 1 minus 4 36ths, which would be 32 36ths. Okay, which would be the equivalent to, what would that be? Well, 8/9. Okay, so there's an 8 out of 9 chance that he scores at least 3. All right, so that's a quick and easy couple of marks there. Not sure how many that would be, but I'd say probably no more than 4 or maybe 5. Okay, Tim plays a game with his friend Bill now, who has 2 dice numbered in the same way. Bill's score is the sum of the 2 numbers shown on his dice as well. Part B, part 1 says calculate the probability that both Tim and Bill obtain a score of 6. Okay, so the probability that Tim gets a 6, we already calculated. Okay, that was 1 out of 9. Probability that Bill would get a 6 would also be 1 out of 9. So the probability that Tim gets a 6 and Bill gets a 6, since they are independent events, would be 1 out of 9 times 1 out of 9, which in this case would be 1 out of 81. Okay, part 2 is the probability that Tim and Bill obtain the same score. So that's the probability that Tim gets a 1 and Bill gets a 1. Okay, whoops, I want to do this. Plus the probability that Tim gets a 2 and Bill gets a 2. Oops, Bill gets a 2. All the way up to what we had just calculated, which is the probability that Tim and Bill both get a 6. I'm going to do a couple calculations here on the side. Actually, you know what? We'll just do the initial setup right away. So the probability, hold on now. Cancel this one. Oops. Bill and Tim can't get a 1 because it's not possible to get a 1. So let's start here with probability that Tim and Bill both get a 2 up to the probability they both get a 6. All right, so the probability that one of them gets a 2 is 1/9, but for both of them it'd be 1/9 squared. Probability that one of them gets a 3 is 4/9. So we're going to take 4/9 and square it. I'm taking all of these probabilities from this table up here. Probability that they both get a score of 4 would be 12/36, which is equivalent to 1/3. I made a mistake on this last part here. This should be, I believe that's, how many is that? 8 out of 36, which would be 4 out of 18. Okay. probability they both get a 5 would be the same that the probability they both get a 3, which is 4/18 squared. And then we already knew the probability they both get a 6, which is that. Now I'm going to go ahead and do some calculation, add those up, and I'll come right back to this. Now I could have made this slightly easier and made this 2/9 and made this 3/9 and made this 2/9 and made that 1/9, but I apparently didn't want to do that. But our calculation ends up being 19 out of 81 if we were to reduce those fully. So the probability that they obtain the same score would be 19 out of 81. All right, let's move on to part C. All right, let X denote the largest number on the 4 die. Show that the probability that X is less than or equal to 2 is 16 out of 81. All right, so as we look at this question, if we let X denote the largest number shown on the 4 dice, showing that probability X is less than or equal to 2 is equal to 16/81, we need to consider both ends of it. So let's say for Tim, the probability for Tim, that was poorly written, the probability for Tim that X is less than or equal to 2, well, there's 16 out of 36 ways for him to get less than or equal to 2. Okay, you can check the sample space on the previous page if you want to. This reduces to 4/9. And the same thing for his buddy, I think it was Bill. Since they're playing the same game, he's going to have 4/9 as well. So the probability that both, right, the probability both Tim and Bill have less than or equal to 2 as their greatest number shown on a die would be 4/9 squared, right, which will equal the probability that X is less than or equal to 2. And 4/9 squared is, as we see, 16/81. Okay, so let's see how that equates to the following. Complete the following probability distribution table. Okay, so let's think for a moment about Tim and Bill and consider this situation. Less than or equal to 1. Well, that'd be 1/9 times 1/9, which is 1/81. If we know the probability that X is less than or equal to 2 is 16/81, then this has to be 15/81. Okay, which leaves us, since the three of these values, X equaling 1, 2, and 3, have to add up to 1, this must be 65/81. So let's do some work on calculating expected value. Got a little happy there. The expected value of X is going to be each of the X values, so 1 and 2 and 3 times each of their respective probabilities, so 1/81, 15/81, and 65/81. So the expected value of X will be 1/81 plus 30/81 plus 195/81, which comes out to be, oh boy, 226/81. There's our expected value of to 3 sig figs, that is 2.79. Okay, now let's find the expected value of X squared. Well, that will be 1 squared times 1/81 plus 2 squared times 15/81, that's a 15, plus 3 squared times 65/81, which happens to come out to be 646/81, or I think it was 7.98. All right, outstanding. So now we have the expected value of x. We have the expected value of x squared. We can find the variance, which is equal to the expected value of x squared minus the expected value of x quantity squared. So the variance of x comes out 0.191. All right, awesome. Just to highlight, all three of these are really important, but this is a big one. Okay, this one shows up often. Okay, please, I know it's in your formula sheet, and you sometimes can become dependent on your formula sheet, but be aware of the applications of that. Okay, so given that x equals 3, find the probability that the sum of the numbers shown on the 4 dice is 8. So let's use a little conditional probability and write this out here. So find the probability that given, that the sum equals 8 given that x, the largest number on either of the die, is 3. Well, that will be the probability that the sum equals 8 divided by the probability that x equals 3. Now, this sum equal to 8 has to then also have x equal 3 be the largest possible number on there. So I should really rewrite that to this represent sum equal 8 and x equal 3. Okay, it can't just be any sum of 8. So we do happen to know the probability that x equals 3. We had 65 over 81, part of this distribution table up here. But we got to build sum equal to 8 and x equal to 3. So a couple ways you could get 8 with 4 die. Well, you could get it with 2 3s and 2 1s, or you could get it with 3, 2 2s, and a 1. Now, there are 6 ways to get this using permutations and 12 ways to get this using permutations. Therefore, there are 18 ways out of 81, and therefore giving us a probability of 18 over 65. So there you got it. I don't remember what question number this was. Was it 4? I can't remember. Let me know if you got some questions. I'm guessing there might be some regarding how I got the number of ways here, but you can build it. You know, you can take 3 3 1 1. You can take 3 1 1 3, etc. to find your 6 ways. And same thing with the 3 2 2 1 option for getting a sum of 8. So go ahead and try to build those. Otherwise, we can talk on the side. Thanks for watching. Hope it made sense. We'll see you next time.